Welcome to Chapter 6. One of the main ideas of Chapter 6 is exponents. Before we dive into the chapter, we're going to spend a couple days reviewing things that you've studied before about exponents. So with that being said, let's look at the first page. I've given you 3 examples. If you would at this time, pause the video and work through these examples as kind of a gauge to see where you're at with the properties of exponents. So pause the video now. Hopefully you've taken the time to look at these. Let's see what you got for your answers. For the first one, if I'm taking 5x to the 4th and I'm cubing it, that really means I'm taking 5x to the 4th times itself 3 times. So essentially I'm cubing the 5. 5 times 5 times 5 is 125. And then I'm taking x to the 4th times itself 3 times. So here I have 4 x's, here I have 4 x's, here I have 4 more x's. Total there will be 12 x's. So your answer is 125 times x to the 12th power. In the second example, if you think about x to the 9th, that means I have 9 x's that are being multiplied together. Let's see if I get them all here, 7, 8, 9. And then x to the 6th means I have 6 more x's. So in the top I have 15 x's. Another way to get that would be to add these exponents. In the denominator I have 3 x's. And if I have 15 x's in the numerator, 3 in the denominator, we can go back to what we did last chapter, cancel those x's. And in the end, I really should have 12 x's in the numerator. Instead of writing all of this out, which you may not want to do, perhaps you said, okay, 15 in the top, 3 in the bottom. Do not divide these, 3 cancel, so it's not 15 divided by 3, it's 15 minus 3 gives you 12 for that exponent. The last one was maybe a little tricky. We haven't talked about negative exponents this year, but it's something you would have studied in Algebra 1. So there's a variety of ways you could approach this. The main idea is if you have a negative exponent and you bring it to the other side of the fraction, that exponent becomes positive. So I'm going to forget about this exponent on the outside, that negative 2, for a while, and let's just look at the inside of the parentheses. I'm going to keep anything that has a positive exponent, and then I'm going to switch that x to the negative 6 to the top, then that becomes x to the positive 6. If I bring x to the negative 3 to the bottom, that becomes x to the positive 3. And then don't forget that negative 2 is on the outside, so I'm going to leave that there. If I clean this up a little bit, I have 11 x's in the top. So 5 plus 6, total there's 11. There's 3 in the denominator. 3 in the numerator would cancel with 3 in the denominator, so I'd actually have x to the 8th power if I clean up all of those x's. Now, at this point, if I look at that negative 2, that negative 2 needs to go into every term. Or you could think of it right now as if I flip everything in the fraction, so if I bring the 9 to the top, the 4 to the denominator, the x to the denominator, then I can change that to a positive 2. So there's a variety of ways you can solve these problems. I'll show you a different way later, but for now, if I go with this route, then that square has to go into everything. 9 squared is 81, 4 squared is 16, and if I take 8x, or x to the 8th, times itself twice, x to the 8th times x to the 8th, or x to the 8th squared would actually be x to the 16th. So this is your most simplified answer for the last problem. All right, so what did we just do? Here are the exponent rules that we looked at. If I'm multiplying terms that have the same base, I can just go ahead and add the exponents. Now don't memorize this. Again, think about what's happening. If I have 3 x's times 5 more x's, that's where the 8 x's are coming from. Second, if I have 5 x's in the numerator, 3 in the denominator, 3 in the numerator would cancel out with 3 in the denominator. Anything divided by itself is 1. So So cancel, 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 cancel. Here I'm assuming that x is not 0 because you can't divide by 0. And then I should be left with 2x's in the numerator. I could get that by subtracting your exponents. X squared is your final answer. This property, we use the third one. If I take x cubed times itself 5 times, this is what's happening. That would be the same as if I just multiplied the exponents. Total, I have 15 exponents. So if I have a power to a power, you can just go ahead and multiply both of those exponents together. The last rule, kind of similar to the third one that we looked at. So this last one, this exponent needs to go into each term. So if I look, I'm squaring the negative, or excuse me, I'm taking the negative and the 2 to the 5th power. I'm taking the x cubed to the 5th power, and I'm also taking that term in the denominator to the 5th power. If I take a negative to an odd power, that should stay negative. 2 to the 5th is 32. Then I get that x to the 15th, and y to the 4th to the 5th is y to the 20th. This uses that third property that's listed over here. So that's kind of your exponent refresher. 2 exponent rules that you may have forgotten. The negative exponent rule we haven't really talked about this year, but you did last year. If you cross the line, change the sign. So if I see a negative exponent, I can just bring that to the other side of the fraction and it becomes positive. Now make sure you're leaving a 1 in the numerator if you have something like this, not a 0. If the exponent is negative in the denominator, I can just bring it to the numerator and then that would become positive. But probably 2, not 3. So 6 squared is actually 36. So if I see that negative exponent, I move anything that's attached to the negative exponent to the other side of the fraction. And then again up here, I can't be dividing by 0. Another property, any non-zero number to the 0 power is, let's take a look at this. 2 times 2 times 2 times 2. That's actually 16. 2 cubed, 2 times 2 times 2 would give you 8. 2 squared, 2 times 2 is 4. 2 to the 1st power is just 2. And if you follow the pattern here, looks like we're dividing by 2. Guesses as to what the answer should be for 2 to the 0 power? That should actually come out to be 1. So if I take 1 times 2, I get 2. Times 2 is 4, times 2 is 8, times 2 is 16. So any number to the 0 power is actually 1. And you can't take 0 to the 0 power. So any positive or negative number to the 0 power is not 0. It actually comes out to be 1. Here's another look at why that happens, and we'll do this more later on in the Algebra 2 book. But if I graph this function, 2 to the x power to get out y, I'm just going to be plugging in things for the exponent. So if I plug in 3, 2 to the negative 3rd, cross the line, change the sign, 2 cubed is 8. So that means if I plug in negative 3, I actually get out 1 over 8. So here's the point, negative 3, positive 1/8. If I plug in negative 2 for x, this is what comes out for y. If I plug in negative 1 for x, I get out 1/2 for y. If I plug in 1 for x, I get out 2. 2 squared is 4. 3 squared is 8. And then if I connect this, I actually have an asymptote, which brings me to the bottom here. If I take any positive number and I raise it to a power, there's actually no way that I'm going to get out 0, and there's no way I'm going to get out a negative number. So any positive number raised to a power is positive, meaning all of those y values in my table are positive. And then if you see on the graph, 2 to the 0 power should actually lie right here, and that corresponds to another reason why 2 to the 0 power is 1. Okay, so with that fun fact, continuing on, I have a few examples for you. So if you want to pause the video, write down what you think the answers to these problems are going to be. Hopefully you've come up with some answers at this point. Anytime I see a negative exponent, just bring that to the other side of the fraction. So the 10 to the 5th can stay put, but since I have a -3 and a -4, I'm going to move those to the denominator, make the exponent positive. Then I can apply that rule of, okay, I have 3 tens, I have 4 more, add those together, I have 7 tens in the denominator. And at this point, 5 tens in the numerator would cancel out with 5 tens in the denominator, which would leave me with 2 tens in the denominator, or if you want, you can write this as 1 over 100. Second example, this one's maybe a little bit tricky. The -4 is actually only attached to the 2, not that negative out front. So I'm going to keep the negative where it's at in the numerator. Remember, this is like 2 over 1. So I'm going to keep that negative in the numerator, and then I'm actually going to move the 2 to the 4th to the denominator, and since I moved it, that exponent becomes positive. So now I have -1 over 2 times 2 times 2 times 2 is 16. That's your answer. Here's the difference. If that negative would have been attached to the exponent, it would need to be in parentheses. Then I move that whole thing. Now the exponent is attached to whatever comes right before it, which is what's in parentheses. So the negative and the 2 is going to move. And then this would be positive 1 over 16. So be very careful on this. Same thing that happens if I type this into the calculator, it's going to say it's -9. If I use parentheses, this means -3 times -3. This first one means the opposite of 3 squared. So careful on what's attached to the exponent. 2 more examples, so pause the video and give these a try. Let's take a look. X to the 0 is 1, and I should preface this by saying x can't be 0 here, so if x is anything except 0, that's just 1 times x to the 7th. In the denominator, it's like x to the -3 times x to the -3, so total that would be x to the -6. You can multiply these together to get that. Now that I have a negative exponent, I'm going to bring this to the top of the fraction, and the sign should change. So I have 7 x's and 6 more, so total, this is x to the 13th is your most simplified answer. On the bottom one, there's a couple different ways you could do this. I'm actually going to start, since I have negative exponents inside the parentheses and outside, I'm going to take this exponent to each term. So if I write out what's happening, it's like 2 to the -1 to the -4th. I've got z cubed, that's also being taken to the -4th power. Z to the -5th is being cubed, and y is being cubed. So I don't know if you wrote this first step, perhaps you don't have to. Really what's happening then is I have 2 to the 4th, z to the -12th, z to the -15th, and y cubed. Now there's a couple different things you could do. If you wanted to, you could add these exponents together right now. I'm just going to bring them to the bottom of the fraction. So 2 to the 4th is 16, 2 times 2 times 2 times 2. The y cubed stays because that exponent is positive. And I'm going to move these z's to the bottom. And then last thing, combine your like terms. If I have 12 z's and 15 more, I actually have 27 z's that I'm multiplying together. So that is your final answer. You may have used a different method to get to the same answer. There's many times lots of different routes you could use, but this is where you should end. Okay, with that being said, if you feel like you need extra practice, I have one more example. So if you're still not quite sure, if you're getting the hang of it, maybe take a look at this one, pause the video. Now, a lot is going on with this video. Again, there's lots of different ways you can approach it. So I'm going to, since I see there's an f in the numerator and the denominator, I'm going to go ahead and simplify those. So I have 3/4 I'm going to bring this h to the top right now. So h, if I bring it to the top, that negative 1 would become positive. And then 4 f's on top would cancel, excuse me, 3 f's on top would cancel with 3's in the bottom, leaving you with 1 f in the numerator. And then I haven't done anything really with that exponent on the outside yet. Here on the second one, I could bring this to the top and make that h to the 5th positive. You know what, I'm also going to reduce the 4 6. 4 over 6 is the same as 2/3. And now I'm going to attack this negative exponent. So I could take this into each term and then flip it, or I could flip and then make that exponent positive. So that's what I'm going to choose to do. This would be the same as saying if I flipped the fraction, made that exponent positive, and then the second fraction is just going to stay the same. Now I'm going to utilize this. If I'm squaring, 4 squared is 16, 3 squared is 9, h times h, and f times f. That exponent needs to go to everything. Here, fraction stays the same. Now, if I'm just multiplying fractions, go across the top, across the bottom. So I have 32 f squared h to the 5th. 3 times 9 is 27, h squared, f squared. And then lastly, I'm just going to want to clean this up a little bit. F squared over f squared, those should cancel. Anything divided by itself is 1. And then if I have 5 h's in the numerator, 2 in the denominator, that would actually leave me with 3 h's in the numerator. There's a 32 up there, and there's a 27. 32 and 27 don't have any common factors, so that's as far as you can go. That's your most simplified answer.